In this short video, we will explore how to perform geometry parametrization in EDEM using HyperStudy and InspireStudio. The first step is to create an environmental variable in your system that will tell InspireStudio to automatically export a geometry, and we will utilize this environmental variable later. That is how the variable name should be defined. Pay close attention to the name especially. Once we have defined the environmental variable, we can create our geometry in InspireStudio as usual. In this case, we have a drum with some lifters created via radial symmetry. We can use design tables to parameterize every stage of the geometry's creation. So in this case, we are parameterizing the number of lifters in the polar array as well as their extent by parameterizing the extrusion distance. Once we are happy with the parameter space we've defined, we can export a parameter table that HyperStudy can recognize and operate on. Going into EDEM, we need to define a dummy geometry in EDEM, in this case this box, which will be replaced every time by our parameterized geometry. The rest of the setup in EDEM is as usual. We need to define a factory to introduce the particles. Any motions on the dummy geometry will be maintained for the replaced parameterized geometry. Going into HyperStudy now, we need to first create a model for InspireStudio and point to the parameters table that we exported. We also want to give the extension of the geometry file we want InspireStudio to export, and in this case we want to export an STL. If we import the variables, you can see that HyperStudy recognizes the variables in that parameters table, and we can define the parameter space as usual. We now run the definition for the InspireStudio model, and what will happen is InspireStudio will create a geometry with the given set of parameters, export the STL geometry. Once this is done, we can check in our folder tree that in our test run we should now have an STL created by InspireStudio with our new morphed geometry. Now we can add an EDEM model as a second step and point to our EDEM deck. We launch the connector, and here we can parameterize any other EDEM parameters that we would like to have access to. But importantly, we need to add an option here in the EDEM run flags that tells EDEM to replace a geometry from a file. And we need this text file, configuration file created that tells EDEM which geometry file to use, in this case our STL created by the InspireStudio. So once we've defined that configuration text file and told EDEM to use it to replace a geometry, we can proceed as normal. If there are any other parameters that we're interested in this case, for example, the rotational velocity of the drum, we can also include that. And then we have our full parameter space, both the geometric and the operational parameters. Now it's time to add some model resources to the EDEM model. And in particular, we want to include, first of all, the STL file that InspireStudio has created. And we want to set that to copy. We also need the configuration text file that tells EDEM how to replace the geometry. And with this, we are ready to test the EDEM side of things. In this step, EDEM will HyperStudy will copy the geometry from InspireStudio into the EDEM model folder, tell EDEM to replace the dummy geometry in our model with the new geometry, and run the EDEM simulation. So if we look at the result, in our model tree, we now have an EDEM deck, and as opposed to the original, the new one will have the new geometry instead of the dummy geometry, and we have a simulation complete as well with it.